Okay, so we can start, I guess it's time.
Yes.
All right, great. Hello, everyone. I'm Uzair. I'm a trainee. I'm a Discover trainee in Vodafone in Technology and IT. And today I will be presenting a topic that I'm currently involved in, that is Mobile Edge Cloud in 5G. So before we start a presentation, I would like to show what you're going to expect through the next 30 minutes. So I'm going to introduce you to what Mobile Edge Cloud, what MEC is, what are the different types of MEC, how it is important in terms of its use cases and its role in 5G, and what Vodafone is doing in terms of that, and what are Vodafone's plans with that. And then I will conclude by saying some remarks on the future of MEC and 5G. Well, before I start my presentation, I would like to say that we will definitely get some time at the end of the presentation for question answers, but during the presentation, if you don't understand anything, or if you want me to repeat something, or if you have some questions, just feel free to ask me and I'll be happy to help you. All right, so let's start. So what is MAC? MAC stands for Mobile Edge Computing, Mobile Edge Cloud, Multi-Access Edge Computing. All of these things, they refer to the same concept, which is a network architecture concept that enables cloud computing capabilities at the edge of the network. So that means that it brings the cloud computing capabilities from the cloud close to the user at the edge of the network. The idea comes from that with the arrival of technologies like 4G, 5G, IoT, which require higher data transmissions, highway processing, and lower latencies. We needed to have a solution where we can address these problems, where we can save on the data transmission times and also provide higher data processing capabilities. So obviously different businesses and different companies, they were looking for such one solution, and then that is when the Mobile Edge Cloud came into existence. There are different initiatives that are currently looking into the concept of Mobile Edge Cloud. One such initiative is Open Edge Computing, which is a collaborative initiative between different universities, different companies that are involved in this topic, and they are looking to actually drive the business opportunities and the technologies around Mobile Edge Cloud. So big names like Microsoft, like Vodafone, Intel, VMware, all of these companies and universities, Ivy League universities in US, universities in Germany. So they have this collaboration where they meet and they discuss annually and monthly to actually see that what kind of use cases they should focus on, what kind of research they should invest in, and what kind of technologies they should focus on for the future. Before we move forward, a really important thing to know is to have a clear demarcation between cloud computing and edge computing. So when you hear the word cloud computing, it's like that it's a standard de facto for developers and enterprises that want to deploy their applications because of like three most important reasons. That is scalability, flexibility, and cost efficiency. And you can see that cloud computing has been a very, let's say, hit concept over the last decades. But as I said, that the technology keeps on evolving, so does the user requirement and the data requirements. And with that, new applications are coming into existence that have higher requirements in terms of latency, and in terms of data volumes, and in terms of data privacy. And that is where this edge computing is so vital, because it brings all those capabilities that are somewhere in the cloud, in the internet, and it brings it closer to the network. And by bringing it closer to the network, what it does is that it basically reduces the latency. It basically gives rise, or let's say open opportunities for applications that have, as I said, like high requirements in terms of latency. For example, applications like augmented and virtual realities, applications like autonomous driving, where each and every millisecond is important. So that is where edge computing comes into play. And if we are talking to edge computing, one of the concepts that is like really popular nowadays, and it is deployed at so many industries, is dedicated MAC, which I will explain further, which is basically a concept that is bundled with the private network that you provide on the premises of a company, and to provide actually all the data processing capabilities and the cloud computing capabilities at the premises. Having said that, there are two types of there are many types of Mac. There are two types that are really popular nowadays. That is dedicated and distributed. So if I talk about a dedicated Mac, so this is basically an edge cloud, which is typically on a company or industry premises. So to give you an example, let's suppose we have a manufacturing industry, or we have like automotive car manufacturing industry. So they are doing all these kinds of like fancy stuff where they need like data processing for their automation tasks, for their robots, or for their manufacturing tasks, and then they need that this computation needs to be performed on the company premises because data privacy is really important for them. So they don't want the data to leave their company. So they want that everything, all the devices should be connected. The network should be completely private for only their company, their premises, and it shouldn't be accessible to anyone who is outside the company. So what we do is that we provide dedicated Mac there. So these companies, they have their own network available there with their cloud compute, not cloud, like edge computing capabilities there. So all the data processing can be performed there, and the data processing will be completely isolated from the rest of the world. Then there is a concept which is called distributed edge cloud, which is typically located, let's suppose, in different, for example, data centers, which is spread across the country, so as to make sure that all the users that are served within one geographical location, they can access this application, or they can get the latency within the same, let's say, range. So for example, it doesn't matter if I'm in Munich or I'm in Stuttgart or I'm somewhere in Berlin. When I'm using certain application that is hosted on my edge cloud, and this edge cloud is in my data centers, and my data centers are spread across Germany, for example, then I will, no, it doesn't matter where I'm using this application, I will get almost always the same response everywhere. So that is the concept of distributed, and that is the difference between dedicated and distributed. So let's look at this. So let's look at a comparison between classical mobile networks and versus mobile edge cloud. So as I mentioned, that dedicated MAC is something that we are working on nowadays, and it is being actively used. So let's, for example, take an example of an industry where there is like the data that is being performed, that is being computed, and there is, so for example, you have a 5G device that is connected, and the 5G device, now we are looking in terms of latency, that how is it different from the classical mobile network where all these applications are hosted on cloud, and where today applications are hosted in Mac. So what is the difference in terms of latency? So as you can see in the dedicated Mac section, so the since the device, so now the device is connecting over the 5G to the radio unit. So this is typically always 5 to 7 milliseconds, the air interface. And the most important part comes here in the transport, because this app server, which is doing all the computing, this edge cloud computing. So this is, since it is on premises, so the distance that the data has to travel will be really low. So it's going to be somewhere between 1 to 3 milliseconds. So overall, the round trip time between the device and the data which is being processed at your premises and the app server and then coming back is almost under 10 milliseconds. Now, compare it with something with the classical mobile network, where, for example, you have your applications hosting in the cloud, which is somewhere in the internet. And when I say in the internet, you don't know where the application is hosted. It could be hosted in Germany, some servers in Germany, some servers in US or China or anywhere in the world. So then you will have, you again connect to your radio base station, which then the data travels from the radio back to the whole transport network through several regional backbones and data centers, and then eventually end up in the internet. So you can see that the transport time here is almost 18 to 45 milliseconds. And on top of that, when you reach the internet, then you don't know where the application is inside the internet. It could be anywhere geographical location, and depending on that, there could be some additional delay. So it's going to be somewhere around 30 to 60 milliseconds. And now if we look at distributed MAC, so which is a concept which is different from dedicated MAC. So it's going to be the overall latency is going to be around 10 to 20 millisecond, because again, instead of going through several regional backbones and several data centers, you will be directed to the closest data centers, because in distributed MAC, the idea is that it is distributed equally among different data centers across the country so that the user can be served within almost the same millisecond. So for example, you connect again your device to the radio unit, and then the radio unit is connected to the closest data center where you have your servers which is processing the edge cloud. And then you can reach it in 10 to 13 milliseconds. So in total 10 to 20 milliseconds, you will have your distributed Mac application running. So here you can clearly see the difference in terms of latency. And now, if I talk about, let's say, the use cases, then you will understand that why I am emphasizing so much on the latency, because there are, as I said, as the technology is evolving, new use cases are coming up. There are use cases which are in which even 1 millisecond of a time is critical for its proper working. For example, cases like autonomous driving, where a car has to make a decision. Then in that you cannot, so 10 millisecond and 60 milliseconds make a huge difference. So definitely it's going to make a huge difference. That's why we cannot rely on cloud capabilities. We need something where we can have data processing done, and we can have the results of the data much quicker. For example, in gaming, if you guys have been actively playing gaming nowadays, so, or not nowadays, like generally, so you know that milliseconds lags, they can create such big problems for that. Then there are cases like drones, artificial intelligence, IoT. So all these cases are basically the cases in which you will find one common thing, and that is that the latency is really critical. So these are the typical use cases that Mac is used for. I hope everything is good so far. Questions, anything? Okay, that means a yes, I think everything's good, so I can move forward, right? Great.
Yeah, perfect. Just move on.
All right, that's great. So now I will talk about briefly, I will give you some examples of Vodafone's activities in terms of Mac. So recently, Vodafone had a collaboration, and it's going on. It's a collaboration between Vodafone and DFL, where Vodafone is working with DFL to provide actually augmented reality-based app, so which is going to enhance the user experience. So, for example, and this use case is done using Mac. So it's like a typical edge cloud use case using 5G. So, for example, you are in a stadium and you're as users and you're watching the football match. So if you take out your smartphone and you point it towards the pitch, so you can see, so all these statistics that you would normally see on TV, or even more than that, because you will see all the live action happening. So for example, if some player is running, you will actually place your mobile phone towards the pitch, and it will identify all the players and at what speed they are running, what are their statistics, what is their passing percentage, how well they're performing, all these statistics that you would normally not be able to see in a football stadium. When you're watching a live match, you will be able to see that. And this is done because all these events that are happening on the pitch, it's happening so quickly, and you need like the data computation and data processing and all the results of all the code that you're running in your server. So you need the results so quickly. So for that, you need something which is extremely close to the origin of the data, so as to say that you need to have like really less latency, and you need to make sure that the results are available as soon as the actual event is happening. So this is one of the use cases that Vodafone is working on. It's a very cool use case. It's a typical augmented reality use case for football fans. Then Vodafone has a collaboration with Continental Company to actually work on use cases like how can Vodafone use mobile edge cloud and 5G to actually improve the network, the road safety, to actually improve the traffic conditions. And this is a typical scenario of or use case of V2X. So, for example, there is a 5G base station eNode B that is there, and with an edge cloud capability. So all these the smart cars or autonomous cars, so they are driving and they are connected to this one, and they're sharing the data. So, for example, if you are at some place here and you cannot see what is going to happen here, so just to make sure that no pedestrian or no one gets hurt, or there is no collisions between cars, so the data will be available there, and you will get time, you will get response, or let's say all the directions in good time. And like this is a typical use case for protective shield for improved protection for other users. There are similar use cases that Vodafone and Continental they are working on to avoid collisions or even on highway. So the whole idea is actually to have a connection between these different entities, so as to say, these vehicles and these different road users, and to have their processing of data close to the origin of the data again, so that it is available very quickly. Because if you see, if this car needs to take certain amount of decision, and if the data is delayed by certain, even by certain milliseconds, you don't know if the front car is going to brake or if someone just starts crossing the road. So this is like something which is extremely critical. So MEC is really useful in these kind of showcases. Then if we move forward, so for implementing all of these, Vodafone had collaborations with recently between Amazon Web Services and Vodafone. There was a collaboration to actually bring cloud computing capabilities and to increase the cloud capabilities and to bring them closer to the customers. To actually, and the goal is to provide all the customers with ultra low latency with 5G. And that is what we are striving to achieve at Vodafone, that we want to make sure that our customers, no matter where they are in Germany, if they're in east, west, south, north, wherever they are, they should be served with extremely low latency. And when I say extremely low latency, it means that like under 10 milliseconds. So that is something. And if we talk about the typical use cases, as I explained earlier, that Vodafone is targeting in terms of mobile edge cloud. So this is like augmented reality. This is V2X, autonomous driving. Drones is one, and another interesting one that we are working on. Then there is gaming. So we have like a whole department that is focused on whole area that is focused on gaming, on working on bringing on mobile edge cloud services for gaming, and to see that how we can be a key and a pioneer in that as well. So actually, this is my last slide. And in the end, I would like to say that with the advancement and the development in technologies, 4G came, then 5G came, and we know that in the future, it's just going to keep going better and better. The number of devices that will be the connected devices that will be there, that will be connected on the network, will be around 75 billion. That is just an estimation, and I'm pretty sure that it's going to be much more than that by 2025. So we will have really high amounts of data that is going to be produced, and for this high amount of data, definitely the user requirements, they are changing. Users, they need high data transmission speeds with lower latencies and with heavy computational powers. And for that, cloud computing won't be sufficient. And then for that, we would need a solution which can serve the future applications with ultra low latency requirements. And that is where edge computing is going to be so vital. So yeah, that is it from my side. I'm open for questions. Thank you so much for listening. And if you have questions, please, we can now, I'll be happy to actually answer those.